My setup is not super professional. Don't judge. We're going to start in our notebooks on page 54 and 55. The title of today's lesson is called Force Drawings. Force drawings. At any time during this video, you're welcome to stop, pause, and catch up if you need to. Okay. Now, the reason why we draw forces is sometimes we need to represent them on paper. There was one time in a starter, I asked you about a book. I'm going to draw a book. This is a side view of a book. And it was just sitting on a table. So I'm going to draw a table. And I asked you to name the forces on this book. In class, we agreed that gravity was a force and the table was also a force. Now, the way we draw this the way we draw this on paper is we use arrows for forces. Now, the force of gravity is going in the down direction. I think we already talked about. Now, like I said before, in physics, force is always represented by a capital F. However, when you have different kinds of forces, you've got to add something to that so you can distinguish. So for the force of gravity, we write a capital F, but then we also put a lowercase g next to it, and that represents F of g, or force of gravity, and it is going down. Please make sure you're adding this picture to your notes. Now, we also decided that since the book isn't moving down towards the center of the earth, that there also has to be another force that is equal to that gravity force, right? So that this book is at rest, because these two forces cancel each other out. Now, there is a force. It is the force of the table, and there's a super fancy sciencey word we use for any force that opposes gravity, and that is the normal force. That's right, normal. So we're going to put F, and then we're going to put a little n, capital N, underneath it, and that represents the normal force, or the force of normal. Now you can see we have the normal force going up and the gravitational force going down, and they cancel each other out, which means that all the forces on this book are balanced, and the book is not changing its motion. But what about something that is already in motion? Let's take, for example, if we are dropping a book, we're going to draw that book again, but this time there's no table underneath it. We are dropping that book. So once again, the force of gravity is making it accelerate towards the ground. So how do we label that? We have our arrow. Well, obviously it's a force, but what kind of force? It's the force of gravity. If you got that before me, nice job. Your first number is 9. Okay, now, even though we have gravity going down and there's no table, there is a little force, and I think you guys have talked about that in class, but there is some air pressure going on in that book. But is that air pressure enough to keep that book from falling down? No. So how do we symbolize that in a force drawing? Here's the way we do it. We make the arrow for the gravitational force large, and then our arrow for air resistance is just so teeny tiny. The size of the arrow represents the magnitude of the force. So we're going to label this force with a capital F for force, and then we're going to also label it with an AIR for air resistance. That is the force of air. So there's a word for the strength of the force, and that word is magnitude. Your second number is 6. The magnitude of a force is how strong it is, and that is represented by the size of the arrow. So here we're going to put this. These are forces at rest. These are forces accelerating. Okay. For our next two drawings, we're going to come back to our scooter slide. So we're going to draw a scooter, and it's got little wheels on it, right? This time, it's on the ground. This time we're going to use a hand, right? Here's our, I'm going to draw a little hand coming up. There's the sleeve, there's the arm. And that hand is going to push the scooter. So what forces are acting on this scooter once it has been pushed? Well, obviously, we have the force of the hand, right? I'm going to draw it this way, because that way there's room for my arrow to go. I'm going to draw the force of the hand that way, right? Okay, what do we label that? Capital F, because it's a force, right? We're going to call this F of A, because it is an applied force, meaning something outside is applying a force other than gravity or any of the other forces we have names for. So we're just calling that an applied force, a force that has been applied to the scooter. Okay, are there any other forces acting on this scooter? Just like the book, is gravity acting on this scooter? Sure is. So we have the force of gravity. And how do we label that? See if you can do it before I do. F for force, little g for force of gravity. Your next number is 5. Were you able to do it before I did? All right, what is our next arrow? Can you think of it before I tell you? Our next arrow is that same floor. Remember, because even though gravity is pushing down, our scooter's not falling down, so that means there's gotta be an equal amount of force pushing up. How are we gonna label that? See if you can do it before me. Capital F, did you get it? And just like over here, the ground is pushing up against gravity, which makes this a normal force, or F of n. Okay, now we've got these two cancel out, and this force is going this way, and so we pushed it and let go, and so this is all we need, right? Except for one thing. If these were all the forces, and once we push and let go, if these were all the forces, then this scooter would continue moving on at the same speed forever, because as soon as we let go of the push, it's not continuing to add force. So there's got to be something pushing it the other way to get it to slow down, and I bet you some of you can guess what that is. The arrow going this way is actually the force of, we're going to label it with a big F for force, that is the force of friction. And we do a little loopy lowercase f for friction. Now notice I did not draw my arrow for friction as large as the arrow for the push, because that push, that applied force, was big enough to get big enough to get the scooter moving, but then the scooter slowed down enough because that frictional force was stopping it. Okay, now for the last one, we're going to draw our scooter again. Got little wheels on it, okay? But then we're also gonna put our weight on top. So now this is a really heavy scooter. I'm gonna color in my weight so it's obvious that there's something on there and it's nice and heavy. Okay, I'm gonna draw my hand a little bit farther away so you can still see it's there, but I've got more room for my arrows now. Okay, there's my hand. This is my hand. I'll label it so we can see what it is later. I'll label it up here too. Okay, your next number is 4. So what are the forces on this scooter with the weight on it? Well, let's start with the easiest one. Anything on the face of the earth has this force on it, and that is the force of gravity. Every single object on the face of the planet. So can you label it before I get there? F. Good. Are you doing the next one now before I even finish? Of course. If it's not going towards the center of the earth, that means it's got to have a force holding it up against gravity, and that is called the normal force. And then we also had a force, and this is going to be the same size as this arrow, because we're going to push it with the exact same amount of force. So this is going to be the same size force, and this is the force of applied, the applied force, the force we applied to it. But what about this last one? This one, remember Newton's second law, if we push it with the same force, but it has more mass, it's going to have less acceleration. Where do you think that less acceleration comes from? Well, the force of gravity is able to pull it hard here towards the ground, and that creates more friction. So our friction arrow is not going to be as large as our applied arrow, but it is going to be larger than last time because this scooter slows down earlier. So that is F of force of friction. Now, friction always 100% of the time works in the opposite direction of the movement. The opposite direction of the movement. Your next number is 1. So we labeled this at rest. We labeled this accelerating. This is accelerating 2. But then it is also stopping. Okay, so this one was accelerating and then it stopped. So it accelerated positive direction and then negative direction. And this one was accelerating and then stopping sooner. So now you have an idea of how to do those force drawings. Go ahead and answer the questions in Canvas and make sure that these are all labeled correctly in your notebook. Your last number is 8.